Welcome to Muddy Math. Today is day 2 of our 28-day journey to Phi. Today we are focusing on curiosity and clarification. So I'm really glad that one of my students posted on muddymath.com saying, I'm still not really sure what Phi is, how I can look for it, and I think that's great. That means her mind is becoming curious and seeking solutions, seeking answers. And so we're here to clarify that. I hope that your curiosity has been building. What I brought to our live stream today is some pine cones and a tree branch. Again, I was explaining how it's kind of difficult to photograph tree branches, but these are some items that I picked up from my morning walk with my dogs. Because of the rain yesterday, I was not able to get back to that pine tree where I really liked the pine cones. But what we're going to do today is understand, how do I know if something is actually in the golden ratio? And if you have the PDF enhancement, you'll see the understand questions in the upper right hand corner. So how do I know if something has the golden ratio? How do I find the value of a ratio? And how can I find an average value for several comparisons of length from a single object? So in order to do those, we need to really get comfortable with our vocab words. Our vocab words are ratio, irrational, rational, numeric expressions, value, approximation. And these words will give us the confidence to be able to communicate the ideas that we notice in nature. In the enhancement PDF, you see that we can get started with an activity first. So the first activity from our lesson today is measuring the golden spiral that you've seen on all the enhancement PDFs so far in this journey, day 0, day 1, and day 2. And we're going to complete this ratio table using the golden spiral. We already know that the golden spiral is in the golden ratio. It's a fact. This rectangle was constructed using the golden ratio. So if I have given that information, it can help us build our understanding of what the golden ratio actually means. So in this image, you'll see that I have units created, and these actually little mini rulers are broken into 16 equal parts. So I really encourage you to get your paper. Graph paper is my favorite. Any paper will do. But we're going to try to complete this ratio table using the golden rectangle we have here, because we want to know our understand question, how do I know if something is in the golden ratio, has the golden ratio? And what better way to really get comfortable with that than starting with an object we already know is created with the golden ratio. Okay, so a ratio, by definition, is a comparison of two quantities. If you go back to your day 0 enhancement, all the definitions are there for you. But it's really important to press your knowledge and press the limits of your understanding and say, can I create my own definition? Can I recall some of the important components of the definition and then put it into my own words? So a ratio allows us to compare two changing quantities. So in the case of nature, the changing quantities could be consecutive lengths. And I keep talking about consecutive lengths, and you might not be sure what I'm talking about. So I consider a consecutive length on a tree branch from a nodule to a nodule. A nodule is where the tree branch is able to sprout new tree branches, and that's how I'm interpreting it. So from this little twig offshoot to this one, I would consider one length, and then from here to here, I would consider another length from each little nodule. Remember, nature gets broken. Birds land on twigs, they snap. So this isn't perfect, but that's one way I can define how to measure consecutive lengths in nature. In our golden spiral, okay, we have consecutive lengths being the length and the width of the rectangle. So please note that this sketch is not to scale, okay? So in my golden rectangle, I have this, we will call the width of the golden rectangle, okay? And here's the length. And here it's segmented into two other parts. And you can see on your enhancement that the golden spiral kind of spirals in from here. So we repeat this ratio of breaking the golden rectangle into a square. So if you notice, this doesn't look like a perfect square. I can make it more perfect by doing that, kind of creating an arc. And then if that's 10, then I want about 0.6 to be the tail end. So it's going to be about there. So that's a better sketch. Okay, so this square is of side length W, the width of the rectangle, and length is the width plus about 60% of the width. So what I did is I was like, okay, if this is about 100%, then what's about halfway? That's 50%. So I'm going to guess 60% is about there. So I'm just doing a sketch. Okay, so what I know from this image is that W plus, and we can call this X, this 60% length, X equals the length. I know that X is about, and I can use these squiggly, you'll see these squiggly equal signs a lot in this series because approximation is huge with phi, since humans don't have the infinite string of numbers that create phi. We use approximations, and especially for what we're doing, you know, a 1/16 of an inch is a really precise measurement. A centimeter is not as, we can probably get more precise with millimeters, and beyond millimeters for human beings isn't really a necessity. So going with about 2 or 3 decimal places is just fine, more than enough. So we're going to say that this distance is about 60% of the width. Okay, so that's a nice little, some equations we can use to model the golden ratio we have so far. Now, this is within the golden ratio because the length, the ratio of the length to the width, okay, the longer side to the shorter side is equal to about 1.6 over 1. And I know that because if I'm considering the width to be our unit, then the width is 1, and then 60% of the width, instead of x now I can just write 60% of the width, 1 width plus 60% of the width. Combining like terms, I add the coefficients, 1 plus 6/10 is 1.6. Okay, now how do we get the golden spiral to continue? Well, if I have 6/10 of the width and I want to make another square, okay, I'm going to use sort of an arc to help me figure out where that square is. And remember, this is a sketch, so it's not going to be perfect. Okay, and the idea is that however I form that square, okay, it will continue in this pattern that this square is now the unit, and this added segment is about 60% of what we consider the unit to be. Now, if you are a younger learner here, this is a lot of 7th grade stuff. So remember, there's bus stops along the way. You don't have to worry so much about the expressions, but why don't you just try sketching the golden rectangle? You have plenty of models here for you. Go ahead and sketch the golden rectangle. See how close you can come to making a square in the rectangle, making a square in the rectangle until you can't do it anymore. You know, I like to sketch them in my free time, and sometimes they work and sometimes they don't. So just a quick example of a time I did that. I don't have it with me, but that's okay. So back to 7th grade material. So this is the idea of the golden rectangle. Now what we can do is complete that ratio table. Okay, so the ratio table on the enhancement PDF is relating y to x, where y is the longer side, or the longer length, and x is the shorter length. So if you count and you take the time to count, considering the width to be 1, okay, because you can see the scale. Oh, I have it up on here. The scale is that one of those rulers is 1 unit. So if I'm going from the width and the length of the rectangle, I'm considering those to be consecutive lengths, then the shorter side is 1, and the longer side, if I count, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like 10/16. Okay? The example that I have already on your enhancement is 1 to 0.6. Okay? So you can see that here, that if you're considering the lengths instead of from width to length, if you're considering how you break up the length, this is 1 unit, and then this is about 6/10 of that unit. So in the golden rectangle, you can compare part to part, considering the length being, that whole length, part of the length, which is the width, equal to the width to the remaining, or width to length. So you can get creative here and compare them however you want. Okay, so if you count in more, you can get that we have 10/16 to 6/16. I also calculated 1.6 to 1. Okay, these are several different measures that I found in this simple golden rectangle. Take time with this, right? So don't feel like you are learning everything from me. This is a moment where you have plenty of time to be patient and to explore this golden rectangle, and search online golden rectangles for more. Print one out and get a ruler out and actually measure it. There's so many ways to find this value of phi in a golden ratio. So what I want to think about is, how are the lengths related? And this is a lesson in proportionality. Quickly, so what do I multiply the short side by to get the long side? What is the constant of proportionality? And we're going to get into that on a later video. But what do we multiply x by to get y? And that's called the constant of proportionality. And we're hoping that k is approximately phi, which the approximate value for our needs is 1.618, 1 and 618 thousandths. So you can see that these are going to vary a little bit, and that it's not exact in nature. And of course these measurements aren't exact because look, our little rulers aren't that precise, and this isn't very precise measuring, and that's okay. So we're going to have some error, human error, in our measurements, and that makes sense. Okay, so what we would do here is we want to find the value of these ratios and then average them out to see if it equals phi. So we're not going to do that. I encourage you to try that, but I want to give you some background. If you go to Wolfram Math, you'll see that they have a value of phi up to 36 decimal places from this approximation, and this was a more recent approximation, and more on this later, but the approximation is using an irrational numerical expression. So the square root of 5 plus 1 over 2 is an irrational numeric expression. Okay, so the square root of 5 is irrational because we don't have an exact value for what number times itself gets you 5. Unlike a rational number, the square root of 4, because 2 times 2 is 4, so the square root of 4 equals 2. The square root, do you know the next perfect square? Yes, square root of 9. So 3 times 3 equals 9, so the square root of 9 equals 3. So I know that the square root of 5 is somewhere between 2 and 3, and I can approximate that if I drew a number line. Okay, and I also know this is the square root of 4 and the square root of 9. So 5, 6, 7, 8, 5, 6, 7, 8. I want my number line to be closely in equal intervals. So this would be the square root of 5, square root of 6, square root of 7, square root of 8. So the square root of 5 is about 2 and 1, 2, 3, 4, 5, 1/5. So it's about 2.2. Okay, but again, that's an approximation, and that's what we have to rely on is values that are approximately equal to their expressions when we don't have the exact value, and we don't need it. We don't need to go super long in the decimals. Let's continue on to the other understand questions, and then I'm going to let you go to explore and see if your object is living in the golden ratio. So the activity that we're going to look at today is listing the Fibonacci numbers. And again, these have shown the golden ratio by the value found by comparing consecutive numbers in the Fibonacci series. Okay, so the Fibonacci series, you can look it up and explore on your own or stay with me. And we have 1, 1. The sum of 1 and 1 is 2. The sum of 1 and 2 is 3. The sum of 2 and 3 is 5. The sum of 3 and 5 is 8. The sum of 5 and 8 is 13. Okay, so as we're looking, we want to write them as pairs in a ratio table. So 1 and 1 we could put into a ratio table, but remember how we set up the ratio table for the golden spiral, a longer and a shorter side. In this case, they are the same length, so I'm going to ignore the first two, and I need my longer side to my shorter side. Okay, so here I have 2 and 1, I have 3 and 2, 5 and 3, 8 and 5, 13 and 8. Okay, you can follow along on the enhancement PDF or just on a whiteboard of your own or napkin, whatever. Then we want to organize them so that we can determine the value of each ratio. Now remember, a ratio is represented with a colon, a division symbol, the word 2, or a fraction bar. So all I'm thinking about is the value from division. So 2 divided by 1 is 2, 3 divided by 2 is 1.5, 5 divided by 3 is 1 2/3. That's a repeating decimal, 0.66666666, and we eventually would have to round that up to 7 or truncate it to just 6, and I prefer fractions because they're actually more precise. 2/3 is exact, whereas 0.666666, even with that hat on top, is not as precise. Okay, so I'm going to hold on to that fraction as long as I can. And then 8/5 is the same as 1 3/5, which is 1.6. And 13 over 8. Well, let's see. If I have 13 minus 8, then that's 5/8 left over. So I have 1 5/8. 5/8 is 1/2 plus an eighth. So a half is 0.5. A quarter is 0.25. A half of a quarter is 0.125. So 0.5 plus 0.125 is 0.625. Talking about numbers is a healthy exercise for people of all ages to do. You can hear people's perspectives on how they would calculate something and challenge yourself to see what properties of operations you're using. So now we have 5 values of the ratios comparing consecutive numbers in the Fibonacci series. So what you can do is average these out. So calculate the value of each ratio of the longer side to the shorter side, and we just did that. Now to find if phi is really a good typical value for this series of consecutive numbers, you would order the numbers, find the sum, find the mean, median, and mode, and graph the data on a number line. I'm going to encourage you all to try that on your own, and I want you to use mine as a guide. Okay, I included my notes, my anchor chart at the back of the enhancement, and you'll see that to find the mean, median, and mode, okay, you can easily go to Khan Academy, you can go to so many places online, and you need to meet your appropriate edge. You need to meet the edge of your understanding and break through it. So we're all around the world learning at different rates and in different interesting places, but it's up to you to decide where your learning takes you. So my true recommendation is to go ahead and plot the values what you found on a number line and see if you think phi really measures the center of your data. So in this case, okay, this is the activity returning to the golden rectangle from the beginning of our session, and I found the values of 4 ratios that I found in my golden rectangle, and I plotted them on the number line, and you'll see that I think the middle is really good to be phi because we have 3 values super close to 1.6 as it is, and I think that my data is pretty symmetric so that I can use the whichever measure of center that I think really represents it. And so with only 4 data points, you're not going to see a big skew in the data, but you can see that the mode and the median are both close to 1.6. The mean's a little bit lower because of that value of 1.5 that pulled the mean lower. More on that later, but you have a lot of information now, and what's really important is to give yourself time to let it set in. Sit with yourself, sit with these numbers, sit with the Fibonacci sequence, see if you can find phi in the Fibonacci sequence. See if the average of your values really is close to 1.618. If you're not sure of how to find the median and mean, do you need to go research some Khan Academy videos or even some Muddy Math videos on calculating it? I don't have my entire library full yet, but I know Khan Academy does. Or are you just interested in diving down the rabbit hole with the Fibonacci sequence a little bit more? That's up to you. I want you to find your edge today. I hope that you feel comfortable with the understand questions. Do you understand how to determine if something has the golden ratio or not? Do you need more clarification? Please write comments on muddymath.com and I can help clear them up today while you're on your adventure. Finding a value of a ratio, you're just dividing the numerator by the denominator. The first quantity in the ratio is going to be divided by the second, and then that's your value of the ratio. And then how can I find an average? Finding an average is either doing the median or the mean or the mode, finding a measure of center that you think is most appropriate to fit the data. If we looked at the average of these, I went ahead and did it last night, and the median is 1.62. And the mean is 1.66. Okay, and when I graphed the data, you could see that it's skewed right, that one of my values, oh, I'm so sorry. I hope I don't make you sick. One of my values is 2, so this is definitely skewed right, and the mean is manipulated by this 2 value. So here, my median is a much better representation of the data, and that is even closer to the value of phi. So thank you so much for tuning in. Today was our first dive into some actual calculations and mathematical conversation. Please keep the conversation going by joining our Google Classroom. Email me at muddymath@gmail.com to get the class code. You can have conversations with students around the world that are starting this 28-day journey. You can also go to muddymath.com and comment below the post for day 2. Curious and clarity. You did it. See you tomorrow.